is hosted by the Yuma Center of Excellence for Desert Agriculture. For those of you that don't know, we are a public-private partnership housed in the College of Agriculture and funded by the ag industry, both here in Yuma and Central Arizona and the Salinas area. So we try to work on things that are going to directly impact production ag and bring whatever resources to bear on that. So as we do that, we end up working with a lot of really interesting people on a lot of really interesting topics, and we realized, we ought to share that with you guys out there that might be interested. You hear words like big data and irrigation technologies and particularly today you hear about sensors and nano-Sensors and the cloud and all these different things. So like I say, we just wanted to do this seminar series to open up to you guys what do these things mean when we talk about them. So today we brought one of our key partners, Sergio Cardona. He's from a company called N-Mode Technologies. I actually made a few notes. N-Mode Solutions, sorry. He's an electrical engineer. He worked at Raytheon for 17 years. And over there he was a deputy chief engineer over a $600 million program, which I wasn't familiar with, called AMRAAM, a small missile program that's on every plane?
Platform.
Every platform. And the key to that program and that technology was it had to be small and it had to be high performing. So he ended up leaving Raytheon on good terms to develop the nano-Sensor platform because he felt he could be a little more nimble than a big company like Raytheon in developing that. So we're working with him on advanced technology projects, and in particular today I asked him to talk about nano-Sensors and how those could be applied to agriculture, what's that going to do for us in this industry. So with no further ado, I'll turn it over to Sergio.
Sergio Cardona, electrical engineer from, I went to school in Boston, a small university called Merrimack College actually, and started at Raytheon, migrated to Tucson, Arizona, and then I left Tucson, went back to Boston because I thought the desert was not my thing. Then I married someone from the desert, so then I came back. So that's really, and I worked for Raytheon and for a company called Maycom, who was big into radio frequency stuff. At Raytheon, I did a lot of jobs. Primarily, I'm an electrical engineer, focused more into radio frequency, so anything from passive components to active components to sub-assemblies and communication devices, we kind of designed those things. Paul mentioned that I worked on a program called AMRAAM, and one of the things is one of the most reliable products in our defense system in all of the platforms. Every airplane carries an AMRAAM, and one of the things that it has is very high performance, but it has to be lightweight because you got to have batteries to power it. So that gives you a unique characteristic that most people in industry don't really have. You got to be the best in performance, and you got to be the smallest. Typically, when you want to be the best, size doesn't really matter, and you see the big radar systems that are on ships or in the ground, and they're huge and they have a lot of space. But when you want to crunch everything into that type of area, there's a lot of thought that needs to be. You got to be very innovative and push the limits a lot of times. So, founded a company called N-Mode Solutions because I thought that I had figured out a way to do things smaller, smarter, and better. And very passionate about the company. And a few months ago, I learned that everybody has a price, and sold the company in May to a company called Samtech. And so that's where I want to start. And Samtech is known for interconnects, but they also have a lot of capability from the microelectronics world. And they saw N-Mode, and N-Mode specialized in radio frequency type of sensors, nano-sensor technology, in combination with glass technology, which is our core platform. And I'll talk about that. And so we had a fabrication house in California. Samtech saw the uniqueness of fiber optics, radio frequency, and microelectronics, and decided to invest in purchasing N-Mode and at that time Triton. We owned two companies to combine it all into Samtech and create next generation products using glass. So that's really what happened. I want to talk about the glass core technology because it's important, and you'll see how it's relevant to you that you work in the field. I want to talk about wireless smart modules, which are things that I'm focused on particularly around the glass core technology. And bottom line, why does it matter to you, someone to you, like you? And then we'll talk about the sensor platform. We want to create little devices, very small devices that are open source, open to any type of sensor so that you can do your own application and modify it and use it as you wish. And it's low cost, it's as small as you can, and it's as flexible as we can make it. Okay? And then we'll do a little demo to show you the uniqueness of it, and then we'll talk about some market and some applications, and then some capabilities that we have. Why glass? We actually pushed the limit in, personally from my background at Raytheon in many technologies, like anything that's organic, like FR4 type of boards, or even any other laminate of that sort. We pushed the limit on dimensions, on widths and tolerances and things like that, and I kind of understand really well what the limitations are from an organic point of view. We pushed it to ceramics, we pushed it to quartz and glass, and we actually looked at every substrate, potentially almost all kinds of substrates, and we have a good idea of what is good and what's bad out of them. One that we got focused on was glass. Glass represented a solution that we couldn't really find in other substrates, and the ability of being naturally hermetic really appealed to us, and so we started learning new things, new innovative things to do with the glass. We started with being able to metallize the glass on the top and the bottom substrates, with very low cost copper, and we actually make our own metals that have special chemistry that blends or bonds to the glass. And then we said, yeah, that's kind of nifty, that's kind of unique. Well, can we connect the top metal to the bottom metal, put in some holes, and using metal, right? And the answer is yes. People have been doing it for a very long time, but can you do it at microns level? Okay, and so we figured out ways not only to do that, but to fill it or fill those holes with copper, our own copper paste, and we were very successful at doing that. And we thought that was pretty good. And the reason why that's pretty good is because as people are designing next generation silicon, okay, that uses very high density memory and IOs and things like that, the feature sizes start becoming so small that the solutions tend to be very high cost because the substrates can't process that small. So you got the silicon that's very capable, but then you have the substrate that goes below the chip that is not capable to process that, so the price goes up. Does that make sense? So what we figure out is that if we use glass, we can use glass so that we can go to the smallest pitches or dimensions and fan it out to any size we want. So glass allowed us to go from not only the smallest microns type of pitch to inches, all in one substrate. So as opposed to when you do it in other substrates, silicon or organic material, you got to step up and fan out. Okay, so we were able to eliminate all those traces. So that's why we created this, because we can go from nanometers to millimeters all in one using the through glass technology. We thought we were pretty special when we did that. And then we realized that we needed to create a way to do multi-layer structures. And so we invested a lot of time and effort and resources to come up with multi-layer structures around the glass. And that's what's made it very unique for us. Because now we can process and do things and treat the glass as a board, organic board. It's a multi-layer structure. And we can embed things on the glass, making it 100% hermetic, which means, reliability point of view, when you're out in the sun, you don't have to worry about the weather. Does that make sense? And the other thing that's very important, I'm thinking that the computer, I have to press the button. The other thing that's very important is that it's made for high volume manufacturing, which means that it doesn't matter how complex the structure is, it's high volume manufacturing, so it's always geared for lowest cost. So that's the benefit of that. So at the very front, NRE is a little bit higher than organic material, say, but long term is the lowest cost solution. Does that make sense? Tell me if I'm going too slow or fast, or let me know.
You mentioned putting it out in the sun.
Yeah.
And you got electronics encased in glass, and you put it out in 120-degree weather in Yuma. You run into heat problems?
So potentially. So it depends on how we create the vacuum inside the structure. But the glass process is done in 1,000 degrees Celsius. So that's not a concern. The outgassing would be more of a concern than anything else. But so glass core technology, we're not only able to create electrical interconnects between one side of the glass to the other, but we can go from layer to layer to layer on the glass. Does that make sense? It's hard to see, but you can see the pillars on the screen of the glass, and it's phenomenal. Prior to N mode, I never were able, or I never got the chance to work on glass, and then I realized how difficult it is to take pictures of structures that are made in glass, because everything's transparent, so it's really hard to see the features. But you can see that this is a via, a copper via that goes from the top to the bottom, and we can make them 25 microns, which is really, really small. If you're familiar with organic material, if you approach 4 mils, 5 mils, you're pushing the limit. 4 or 5 mils is 200 microns. Okay, so that's a big deal. Okay, we'll go. Some of the advantages why you kind of want this: improves performance. We do things on quartz. Quartz is very low loss electrically, orders of magnitude better than anything you'll find in Doroid material or organic material. It allows us to do very small features, high density, and so it has a lot of good performance benefits. And then also allows us to do 3D integration of the system, so it allows us to be the smallest solution. And then the other thing is hermetic, and we could also do microfluidic channels or 3D structures on the glass. So in the future, I should start thinking about fluids and things that happen and how to connect the fluid world, if you will, to the electronics world. We can tie it all into one substrate. So it's actually pretty. So this is the enabling technology for what I'm about to show you. I want to talk about the smart module, which is probably more attractive and more relevant to this discussion, but I wanted to introduce you to why this matters and why it's different than anything else in the market, okay? So at Samtech, what we're doing right now is creating wireless modules that are self-sustaining. So meaning that, meaning that the modules have their own communication channel protocol. They have a controller, they have a power management solution, and they have sensors. Along with the sensors, it also has the capability to be able to be connected to any other sensor that you have via any of the digital communication channels that you want, SPI, I2C, UART, all of those. So you can connect to literally any sensor that you want through this one little module, if you will, that's wireless. Okay? And all you need is a battery that goes with it and an enclosure. Okay? So enable you to create your own applications. What we want is to create a module or a platform that anyone like you can go and use it and start creating your own ideas or your own applications around it. And we just want to enable you to do that by giving you the module. It's a module that can be connected to a phone, to a laptop, to anywhere you want, so that you can have access to the data anywhere you want. Most of the systems right now for IoT or wearable devices have traditionally the same type of thing. They all have like a Bluetooth or some type of communication device. They have a microcontroller, a power management, maybe a battery, and they got some sensors. Okay, most of them are doing that. What we're doing is putting 3 or 4 sensors as part of the module and allowing you to add more to it if you want, so that you can pass through that data, so that you can create your own real-time applications, or we can change the module to any other sensor you want by any flavor that you want. If you go to this slide here, I don't know if this works. We can change the sensors on the module. We can change the communication protocol. LoRa if you want low range, low frequency, high range applications. Wi-Fi if you're processing video. BLE if you're doing just data type of alert systems. And then we can obviously do custom designs.
So you can put in there some kind of communication technology that even out in the middle of the field, in the middle of nowhere, would get the information out.
Yeah. Yeah, so the background that we have, we're RF engineers by trade. So either changing the communication protocols, changing the frequency, changing the antenna elements, it's all open. It's part of the trade, and we can do all of those things, or a mixture of those things. And so this type of structure, we're trying to make it the smallest device out there that sends alert systems, which translates to power. It's the lowest power device also, because we're using state-of-the-art components that are the lowest powers in industry. It's plug and play. You can hook up to many sensors at the same time. It's app-based and it's mesh network, which means that you can have one node and along with a whole bunch of other nodes, and you can create a mesh network that they can send back that information of all those nodes at the same time. Does that make sense? So basically the same thing that I said before. We have a controller, a power management, communication device. All of these can be tailored to a particular need. The elements that we're creating now are kind of standard, but they can be tailored. And we want to either provide sensors or use existing sensors so that we can create next generation sensors in the future around our technology. That's really where we want to go. Enable new type of sensors, if you will, in the future. They're more integrated. Any questions? No? Okay. So bottom line, we want to be the smallest, best performance or better performance and lowest cost. And you can do it. So we did this module that's 13.9 millimeters by 13.9 millimeters. It has a accelerometer, a gyro, a mag, temperature sensor, antenna, filter, balun, BLE, power management, and it has the controller. All those things into one device All you need is a battery, and it works. Okay, as a communication device, alert system. Okay, and it's a 13 by 9 millimeter. It's made out of organic material. Well, the difference is that if you use a glass substrate like what we're doing, you can get it to 7 millimeters by 7 millimeters. Same functionality. That make sense? And the price goes relatively very low because of the size. Now you can fit more in one wafer. Questions? Oh, and by the way, it's hermetic, 100% hermetic.
So you mentioned using different kinds of sensors on it. Then you have to design the whole thing from beginning to end with the different kind of sensor, or is it more of a plug and play type?
Yeah, so you can just connect to whatever other sensor you have and use the open source architecture that we have to incorporate that sensor data. Any questions? So what does it have? It's using a 32-bit Cortex M4. It has the antenna, like I said, it runs out of 3.6 volts. It really has all of the serial communication that you need to control anything external. You can, control a motor. You can control anything you want from the external world. It has host security, so it's 256 bits encryption, both at the microcontroller and at the communication protocol. It has voice recognition, and it integrates the oscillators all in one. And you can just, in industry right now, if you open a catalog, go to the website, you can get just any sensor, company sensor out there, and you can just grab that sensor and you should be able to connect it to this module and get alerts from it. Does that make sense? Somebody's tagging me down. No questions? Come on. So I'll do a little demo of that. So we have the same type of module, about 14 millimeter square module. It has a little daughter board that it goes to. The one that we're building right now is just that module. This one's just for the power management of the battery that it has in the back, and for the buttons, because they were afterthoughts. But in reality, you can make it as small as you can, and you should be able to just toss it anywhere, and you should be able to have a working module, if you will. So right now I'm going to connect to it. Unfortunately, I can't display it, so I'm going to do it live here, and I'm just going to pass it around.
What's the life of the battery on that?
This one here, I think it's 100 milliamp per hour. Right now we're running 40 milliamps peak, so it depends on the application. It depends on how often you want to wake up and transmit data. But in something similar to this, you could go days transmitting at like 5-second intervals. It just depends on the bursts.
But you can remotely control it.
Yeah.
You just turn it on when you need to get a reading and then turn it back off.
So all I did, so let me just show you. So all I did is I opened up my app. That's why I said you should be inside, closer by. I open up, go ahead.
Can I download the app to lock? Is it possible to download the app?
Yeah, actually, yeah, you can. Let's see. So now I got to know the name of the app, right? So let me give you one that works.
How long would it last if you just wanted a single reading every day at a certain time?
Got to go through the math of that. Who asked the question? You did. We got to go through the math. It depends on how big your burst is. But if you just do it once a day, you said, it's gonna be weeks, months close to maybe years. It just depends on the battery size. But it's something that we just got to do. So do you have an app, iPhone?
Yeah.
So look for an ST Blue MS. So all I did is connect to it. It's connecting to it, and it shows the temperature and the barometer, and then the moisture. I can blow on it, and the humidity changes. You can't see it because you're too far. I told you. But look, it has the accelerometer. So because it has the gyro and accelerometer, you can change it real time. See that? See? You can go and say that you want to plot the data and you want to look at the accelerometer. You can just tell it by a few commands. Just select, and you see how it's plotting data. Can you see that far? And you can move it, and you can start seeing the plot. You see that? If I do this, it's real time. Right? You can do simple things like, emotion, but I'm not going to start running. So, but let's do one that's kind of fun because it's simple. You got an LED. Say you have a motor or something, a switch that you want to control. Turn it on, turn it off, turn it back on, turn it on, turn it back on through the app.
And that could control a valve or a motor?
Yeah, yeah. It's just, what is it that you want to do?
Does that valve or whatever you control have to be wireless, or is it wired?
You wire into the module. That's the idea. So we want to make it as small as possible so that the form factor is as small as possible. But you can, if somebody wants to try it, see the, humidity. If you want to plot the humidity here, and I can blow on it. See if I can say it. You see how it's changing? It's changing real time. You can do microphone if you want to just sense, or I don't know. Actually, I like this one better. You can just twist it.
Do you have a sonic sensor on there?
No, I don't. I do have a microphone in it. So.
Can you give us some examples of how this is actually used, other than the demo?
What-
Aircraft, tractors,
Yeah. So one of the things. So say that you have a field, right, and you want to measure moisture on the field. Every day, or stop buzzing. Every day, or sometimes a week, or whatever. You can actually literally, put well, this one has a moisture sensor, but it's embedded in here, so it's not the glass version, so don't recommend you do that. But you could have like an external sensor that you use every day in the field with you, hook it up to this, and collect the data. And all you have to do is put a battery into it, create your little enclosure, and put it in, however far you want, however you want the grid. This is BLE, so it's probably going to go about 200 feet. But you can create a whole bunch of them, as many as you want, and you can ping pong the data, or you can just mesh the data to give you something that's close to your gateway, that's close to your house, so that, or your office, so you can collect the data. So you can do it for plants. If you have, a container for logistics, I can see how you can put something like this and put a magnet in there or a strap, and you put it into the container, and now you can track it. And you'll know whether you dropped it or you didn't drop it and things like that. And you can create an alert system around that. You can put it in a tractor to measure the speed. In the future, you can know the GPS coordinates, if you will, because if somebody has a phone with them, you know the GPS coordinates, where exactly it is. But you can add a GPS into a module. You can make it so that it connects to a GSM module that can send data or video anywhere in the world. It's relatively easy to do that.
Yeah, I work in a seed company, so you
said there's ones that are wireless. If I have a warehouse in Salinas
Mhm.
and it's in a wireless network, could I monitor it from here in Yuma? Like if I'm connected to the internet, you said there's Wi-Fi. Or do I
Yeah,
need to go
so-
to the same network?
So, yeah, it depends on how you want to do it. But so we're going to have this module here, have something similar to that connect to the computer, and it receives the data and puts it in the internet, however you want. You know, that's an application backdoor that you can have. You can also create something like this and have a GSM module that receives the data through Bluetooth and resends that information into the cloud. That's another way of doing it, and you'll get the alert systems right away. Yeah, should be able to do that.
So you could have these sensors out in every field in your farm,
Yep.
some kind of grid,
Yep.
watching moisture or watching when you need fertilizer or anything like that, and it could feed into a system that's
Right.
alerting you when you need to.
And my interest from a business perspective in the future, we want to sell or provide these modules to anyone so they can do their own application. But we really want to integrate the sensors as much as possible. So if there are sensors that are like, gee, you know, it's this big, if it's a chemical type of sensor, and we really want to make it small, and we figure out a way to innovatively make it small so that people can use it, we like to integrate that as much as possible. That's really our vision where we want to go. From a platform perspective, this is just an enabler to get us there. So we look forward to working with people that are, you know, like Kurt and Paul, that are working with the university, trying to meet real needs in the farm or in the agricultural world. And if something doesn't exist, we'd like to participate to figure out how to make it exist. But right now, there's so many sensors out there that people can just buy. And the question is, you know, a lot of them are not wireless. A lot of them require some type of firmware or some type of work that goes with it, and it's not compatible with something else. And now you have this Frankenstein thing that you want to make it all work. Well, this device allows you to be as integrated as you can be with any sensor that you have. So that's the power of it. So, any question?
What you said the distance or working radius on it was 200 feet, you said?
Yeah, because it's low energy BLE.
And so, but if you mesh it together, they'll talk to each other.
Mm-hmm.
So every sensor you put out at 200, call it 150 feet, you say, to expand your network, will talk to each other back to whatever your base station and transmit your data is.
Yes. Yeah. So, and I think that's pretty elegant solution, you know, because a lot of people will try to blast information, which is okay. I mean, there are some real reasons why you want to do that. But if it's a relatively small operation and you want to keep it as low as possible, low cost as possible, this is not a bad idea to do that. And there are minimal things that you can do to boost the signal so that maybe you can go from 200 feet to 1,000 feet or 2,000 feet and still be compliant with FCC regulations, you know. There are things that you can do that are relatively inexpensive. So without having to recreate firmware or software. And that's what we were talking about earlier, that, you know, if you make small adjustments to the hardware, you know, you can change the frequency domain or the range, if you will, just by hardware with a small adapter, and you get to reuse all the firmware that you used before, as opposed to how most of the people in the industry do it. They want to change the frequency, say at, you know, below sub gigahertz because they want the range, and now they have their own protocols, their own type of modulations that you have to relearn again to communicate with something else. This way, you can change the frequency domain, change the range, and still use the same modulation scheme. So that's a good compromise.
So Troy said he wanted to know what the nitrogen level was at any given time on his whole farm.
Mm-hmm.
And you're talking about developing sensors specific to things. If there's not a good sensor out there to connect to it,
Mm-hmm.
then you could design one into this.
You can. In fact, one of the projects we did earlier this year, actually late last year, was that we had a boundary scan. What's it called? I forget the name. It's been too long. So it's a boundary scan. It scans the soil and looks for the wavelengths of nitrogen, different types of nitrogen, and then it captures the data in real time, passes it through BLE to a remote location. And it's something that's looking at the soil. It wasn't hermetic at that point, so it was more of an engineering solution. But you can do things like that.
And what's involved, time-wise, cost-wise, to have somebody like you integrate that into a module?
We have to look at the specific details, but a lot of times, I mean, for that project, it took us probably about 2-3 months to get to something that you could go and take it to the field and take some data. It just depends. Like, for example, you know, the person we were working with didn't know what type of nitrogen they needed, so then we had to collect soil samples and scan what type of, you know, wavelengths they were looking at, because the papers that we were looking at, nothing really correlated to the data that was published. So we had to kind of do a trial by error type of thing. And then once we found what we were looking for, the wavelength that we were looking for, then you just customize to that. That was my short demo. Anybody want to see it? Did you load it?
Yeah, but it's not finding me.
Yeah, because I turned it off. On that. So when it blinks, you turn it on. Try to connect now. You got it? So if you go to your, let me see. I'll let you play with this. Let me go show. If you go to, yeah, so if you blow on it, on the one, yeah, you see the moisture changes?
Right.
And then if you change that, you do that. Yeah, isn't that cool? Yeah. And it's real data. It's data that you can access, put it on your computer, and post-process.
Can you set alerts and alarms?
Absolutely.
Is it
The app doesn't do that, but you have the data to do that. That you just modify your software that says, okay, if you're at this trigger level, do this, do that.
Does it store data?
The app doesn't, but you're able. You have the data. The data gets flashed to you, or it's transferred to you via the computer or the app, and you can just store it as a file anywhere you want. Yeah. I mean, it'll take more work to create a real alert system that's adjusted to you per se, you know, but it gets you almost there in almost a day, you know. Yeah, I mean, it's very little work that you got to do.
And compared to this, you would have it encased in glass, right?
Right.
So it'd be totally impervious to
Right.
moisture, dirt, anything.
Yeah.
So I would set that out in the field, let's say I was measuring humidity
Mhm.
and temperature,
Right.
and I wanted to set parameters for mildew. And if humidity was,
Mhm.
so high for a certain amount of days, I can get it to send me an alert to know like mildew conditions are high or
Absolutely.
or something like that.
Absolutely.
But can it detect spores or things like that yet? Or is
Well,
that, like, the next
so
level?
so you gotta put the sensor in there that does that.
Mhm.
So either you connect to it hardwire, or you integrate it into a module like this. I mean, there's no possible way that we can cover all the sensors
Right.
that are there.
Glucose monitor and just stick it to yourself.
Absolutely.
Oh, sugar no.
Absolutely, absolutely. You can do all of those things. And so that's the beauty of the glass technology, because now if you can process fluids through the glass, now you can create almost like a lab in a chip and do real-time alerts. So for disease, for pathogen detection and things like that.
So it sounds like you could make the battery last for a whole crop.
Right.
A produce crop.
So are they, you do 120 days?
Yeah, you could do that. It's just a math problem, an engineering problem. How big does the battery is for the rate at which you want to monitor it and the time. So it's just,
All of my data loggers go 2 years easy off a coin battery.
yeah, I mean,
There's plenty of-
because it goes, I mean, it's on like in microseconds and it turns off. When you do that math, you can go so many days and weeks and months that, you know, it's just hard to predict if you don't know what the timings are and how often you do that. It's just an Excel calculation that tells you, yep, you're going to last 2 years, 10 years.
So the other half of my question though is if you can put it there and leave it there and it's got power for your whole crop, is it cheap enough that you can then just disk it in when you're done and not have to collect it again?
Right. I mean, that's an option because if it's, you know, you could do that because it's low cost. Right now in production, our target price for this type of module, when it's out there, it's below $40. Right now, if you want to buy it, something like this, at prototype phase really, is about $150. That's how much it costs. But you can reuse it at this point and just keep on using it for many applications. You want to do the dice? That's kind of cool. Did you try the? You tried it? Okay. Any other questions?
What sort of accuracies do you have on your gyro or some of your instrumentation?
You know, we have to look at the data sheet. It's using a catalog accelerometer and gyro. So we got to look at the data sheet in detail. To be honest with you, I don't know that detail yet. I don't remember. I don't remember that detail, but I can get you that information if you want. Let me see if I have it here. No, it doesn't have it. No. I apologize. I'll get it to you. Any other questions? So again, we want to enable all kinds of applications to do that.
How about security with the Internet of Things?
Yeah, so the BLE is encrypted, and the microcontroller is encrypted. So you got 2 layers of protection at that point. So you can do, you know, asset tracking. Obviously, you can do mining, agriculture. You can do lighting, gas, you know, all kinds of stuff. That you know, it's just what's in your mind. What do you want to do? And then again, from a capability perspective, we can change sensors. We can do communication channels if you want for range and things like that, or we can create your custom type of module, or you can just buy it as it is.
You make them both that way and in glass?
Yeah, so right now, so what we're doing right now is we're going to provide a version of this module, you know, so people could just buy it, right? So that's one version. The next version that will come up is it's all glass. So you won't be able to do, you know, you would have to enclose it into something else for the battery and things like that, but it'll be all glass and it'll be smaller than this.